Hello there. Welcome to the archive. We'll design a board today. Or well, at least start. Wait, what? Is it... What's the audio jumping? Or something? Or was that just the player? Wow, wee, wow, woo? Hello. Yeah, okay. Hmm. Hello? Beep boop? Okay. Well, okay, I will keep that in the background. Just so I can monitor. Now the question is, should I do it online or locally? I can do it locally with KiCad, but honestly it's just a lot more convenient to do it online. So we're gonna head over to JLC PCB, I think. Or no. LSCS designer. I always forget the name of the designer thing. Eh. Uh, I wonder if Google understands me. ECDA, yes it does. I've used this before. And I think I kind of started, but yeah. New project. Microbot PCB. It's only gonna be one PCB, so here we have our first sheet. Sure. So let's start plopping down components. I let's let me open up the actual model I made. There it is. That's the wheel. And at the end I kinda just stopped using constants and I kinda just wanted it to be done, so the body is not depending on constants. Sorry. However, this right here is the Microbot. The diameter of these motors is 10 millimeters, so it is quite small. Now the internals aren't really that detailed, but this is the case that I made and that I have a prototype in. However, it's basically point-to-point wired, and I hate it. I absolutely fucking hate it. Which means I will design this board, order 5 of those, and I will make the rest of the bots with basically a pre-assembled board that I only have to solder up the battery and the motor to. And maybe the actual connector for the ESP. But that's far less wires than what's packed back down here now. And it will also improve my charging efficiency, hopefully, which if I can use Schottky diodes instead of a transistor in a weird configuration like I have now, I can get better charging at a lower voltage, which means I can switch to another panel which is lower voltage but more amperage, so it can hopefully be sustainable. Theoretically it should be sustainable already, but it isn't, because I don't have enough light, I assume, and I don't want to smack more lights in the box I have for these, so yeah. Speaking of, let me go get the bot. Let's go get it. That was probably loud, I'm sorry. Here it is. Let me switch to something like so. Here it is, in my hand, being small. And as I said, it's point-to-point wired, which means you can basically just lift up and have a peek inside. There's a big old capacitor there, and some other stuff, and it's shining away. The ESP is currently in light sleep, or it should be, so it shouldn't take that much current. But yes, that's 6 keyboard keys. That's that thing. Basically the same width and size if you don't include the wheels. Either way, I need a board that fits down at the bottom right here. And as this is done right now, it's kind of bad, and focus is not gonna help, but you can see the capacitor there. below that there is actually a little boost converter, so we can get our 1.5 volts up to, or well, 1.2 volts up to 3.3 volts, and it's borderline not enough for some reason. So starting the ESP from that boost converter is a bit hit or miss, so you'll end up connecting it and disconnecting it. Maybe it's some kind of surge thing, surge currents. Either way, it's working, it's nice. Now, charging. As it's set up right now, you can't really see this at all, but this is the battery. Here's the positive terminal. You can't really see it, but there's a lead here that goes to this black package. See it shimmering there, this black thing? That's a transistor. Normally you would have a diode, but transistors act as diodes if you have them in a correct configuration. However, the configuration I have here is that the power from the panel comes into the base, which means it will try to flow to either the emitter or the collector. However, the collector is hooked through a resistor to the ESP, which is pulling it up, which means effectively the solar panel is turning on the transistor to pull down a weak pull-up, but the current, I hope at least, the current going through the base to the emitter is larger than the one going through the collector to the emitter. I haven't actually checked if that's what the charging issue is. However, I'm about to solve it anyway by just excluding that weird thing by designing a proper board for it. But yes, that's the kind of scale we're going to be working on. That's this, and here's where the motors were, as you saw. Pretty faithful recreation, I must say. But yeah, there's the motors, and behind there is where all the circuitry went. And we're gonna make a board, oops, that fits just, it fits just there somewhere. I don't know if you see that. I will see if that shows up. It does show up. Interesting. Good to know that you can use Windows Screenshot to be like, yeah, this thing, or like, yeah, or this, or just mark stuff. Wait, could I? Huh. No. Oh well, whatever. Weird. But yes. That's where the board is gonna be. Luckily, we can get some measurements from this model I made here. If I can just remember how I referenced everything. However, given just from looking at this, we can pretty much assume that the motors are in the center. Well, they are on this center line, which means 5 millimeters from here. Well, technically 4 because there's an indentation, but who knows, maybe they make these motors with the indentation twisted around. I don't know, I have to account for that. So, 5 millimeters from there brings us to this edge. and we'll probably take a millimeter more for clearance. So that's 6 millimeters plus whatever is left on the inside here. And what's whatever is left on the inside there? I don't know. It's probably defined here. Or here probably, yes. Shell thickness is 2 millimeters. I did define that. I set up a temporarily foo to be motor length and gearbox holder thickness and motor assembly clearance. What's the assembly clearance? I forgot what that was. Oh yeah, that's if you have the two motors, like the distance between them here, it decides the chassis width essentially. It's a fudge for that. So that's something in this axis. Yes, motor length and the gear holder thickness. That's holding it on. Yes, yes. And half of the assembly clearance, and then multiply all that by 2. Okay, yeah. So that's something with that. Not something we are interested in though. Actually we kind of are, because we are going to need that reference. Can't I just like measure on the model I made? That would be stupid. It would be easier. Or well, it's technically more correct to go and get the measurements from the definitions directly, rather than measure it off the generated model. So, maybe I should have commentated what this actually does a bit more. The difference of a translation of a difference of a translation of a cube and a cube. Okay, so that's the actual body cube. From that we can get that length, which is just foo. Okay. Can I print? Is printing a thing I can do? Is log? Oh, it is. Can I like clear this window? Yeah, clear. Nice. Hooray, open source software. F5. You didn't log. Ignoring unknown module log. Excuse me. OpenSCAD log. Log print. Debug print, yes. Debug print. Apparently. No. You lied. Print to console, yes. Echo. Fine. 33.5. Which means the board will be 32.5. I guess we shall start noting these things down. What did we say? 33.5 negative 1 millimeter? So 32.5? Why? 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 Why can't I multi-line? Not even with shift? You bastard. Aw. No. Is there a no-op? Now there is. What? Okay, so that's... Wait. I have trouble understanding what I'm looking at. I mean, I designed this and I'm like... Well, I do remember how I did this, but I just don't remember what part of the code does exactly what. And since this is the section where I kinda said fuck it, instead of having it actually laid out sensibly like here, like here it's all derived by the constants above, and the only like numbers you have is divided by 2 or 90-degree rotation, which is basically an axiom translation anyway. And here I just went, well, oof. Yeah, the wheel I did last, that was really just plop in values. But yeah, I did take care with the motor assembly, the battery, the solar panel, the driver, MCU, all the intern, well, this was just kinda... Well, yeah, that was also well defined. But then you come to body and you're like, bruh, what the fuck? What's that 14 there? What's that for? Like, what? Oh. Interesting though. That it can maybe encapsulate it like that. Although printing that would be oof. Yeah, we can set that to like 10,000 I assume. Yeah. It's not centered so that won't affect the bottom. And let's see what this is now. That's a difference it takes off that, so okay, yeah, that's that. And this is that. What is this then? Is that the actual gearbox? No, that's the whole. That's all the whole bottom part of the motor cavity, the slot up from the cavity, and this is the actual, well, this is the actual body, which gets translated from, well, center over there. Yeah, centers that. And then it moves it over by the battery diameter and the motor diameter over, well, yeah, the battery diameter and the motor diameter. So it moves it there, exactly. So we can infer echo that the internal length, well, we know the internal length, it's battery diameter, motor diameter divided by 2, and the solar width apparently plus the shell thickness. Okay, yeah, that's the outer, this is the inner. So apparently I based it on the solar panel length. Okay. So that's the entire length internally. And if we remove the battery diameter, and instead negate so we have the width of the solar panel, and then we negate half of the diameter, and that should be it. And it's 30. So 29. So we gotta make a board that's 32.5 by 29 millimeters. Seems doable. So let's plop some parts. Oh. Yeah, I can't get it soldered on. I'd rather not do surface mount myself, even though I theoretically can do it. I haven't done it before, but theoretically it shouldn't be too much of an hassle. Either way, let's start hooking up some labels. Oh god. Why is this flipped? Okay, whatever. Yoink. Actually, I should probably make that a label. Or a port, as they say. And call it 3.3 volt. Now reset and what's this? I forgot what that was. It's like boot ROM or boot mode or flash mode or something. I don't know. Either way. I should probably go put this back so that people can actually use it and play with it. Oh, and speaking of, it's supposed to be low power. Hold on. It's supposed to be low power, and because Wi-Fi and low power don't really go together, I had to get creative with how to instruct the bots how to move. And that's why that weird transistor setup is there. It's so that the microcontroller can actually read the input on the solar panel as a digital state. And we can actually jump over there and drive it, hopefully. Yes, it's still running. See? We can go full out and just be like, yo. Yeah, like, that's a ping pong ball. We're dancing with a ping pong ball. As you see, I'm limited on pins. But, yes. So the solar panel is actually what's receiving the commands to do stuff. And the ESP is trying to spend as much time as possible in light sleep, so that it preserves the battery. But for some reason it doesn't do that right now, because I didn't do enough testing apparently. Even though I did make a test bot and have this all set up like for a week in my room, and it worked just fine. And then when I put it online, it's like, yeah, battery's dead now. It's like, what? Why? Why do you hate me? But yes, I should get some better suited panels for the application in the mail soon, which are 1.5 volt. The battery is 1.2 volt, and luckily, if we can get Schottky diodes, on this, the voltage drop on those is usually 0.2, which means we have 0.1 volts to push current with, theoretically. At all times, essentially, even when the battery is mostly charged. But yes, I need a connector for the for the boost converter, which is a 3-pin jobby. What is this even coming up with? Connectors, please. Why is it coming up with capacitors? Can I just do... It had a broader category before. Then it was like all connectors, but now it's like, no. Connector. I swear. Why though? I just need 3 holes. Is it a header? I wonder. I wonder. I wonder, I wonder, I wonder. Do I have any one of those boost converters here? If So here's the boost converter that I will use. It looks a little something like so. And may not be able to see, but it has right angled pins on there. I'll probably I may desolder them. I may stand it up on the board. It might preserve more space. How much space do we have? Answer: not a lot. This is another chassis that I'm preparing. Here's the motors. I have to take those wheels off though to get them on because screws, and me not realizing that, but that comes later. There is not a lot of space. I mean, I have like a millimeter. I'll solve it somehow. But yes. And our VCC will be a battery. Which we will also connect with a header, I suppose. Or well, just pads. Yes. That's there. The one not that close though. I don't know. Well, I should probably make it a 4 since I need for the panel as well. Eh. I hit place instead of search. So 2 of those will be ground, one for the battery, one for the panel, and then we have battery voltage and then panel voltage. So just so I don't have to join or split wires, I'd rather have multiple ground points. Huh. Interesting. Ground on 2. Battery on the outer terminal. And this will be solar sense. Well, just solar. Huh. I just realized I might want to make these pads instead of through holes. Ooh. I will do that. For once I actually don't want through-hole parts. And the library is only giving me... okay, there we go. Okay, what was that? Header, surface mount. One by 4. 4 by 1. Ah, yes, they specify total pins. 4 pins. I give you one job. There we go. And that's wrong. Or is that wrong? Just want my chat to be connected. Thank you. So what is this actually? Maybe I can just create pads. Well, I guess I could make 2 different headers for battery and solar. Swaller. So, is it there? Oops. Yes. And we shall stick by convention and connect ground to pin 1. Because that's what sane people do, supposedly. Eh. Header solar, header bats. Fuck. Why? Jesus. So, I forgot which pin the wake up is on. Pin 1. Or GPIO 1. TX. Correct. Yeah, I don't know why I chose TX. Yeah, I'll keep that since that pretty much needs to be standardized. I don't know if left or right is left or right, but it doesn't really matter. What does matter is the backwards pin, because back does both left and right back. So if we switch that around, our turning will be backwards instead of, well, when we turn we will move backwards instead of turning forwards. So I guess it depends on how you want the bot to move. Either way, there's TX, and we will put a label on that saying solar sense, since it's different from solar. I think that's what we want to do at least. Those two will not be connected. Now these. That's uh, backwards, but yeah, let's just say back. And these two are left is free, right is 0. There we go. Left, right, back. Sense, 3 volt ground. Reset and flash, or whatever it's called, yeah. Reset and enable. Oh yeah, GPIO 0 is flash, now I remember. But yes. That's now I just need to do the connection between solar sense and solar, and between solar and VCC. So, we have solar, we have our grounds, we have our VCC, and sense. So yeah, so the VCC is battery, basically. Now, let's see if we can get a Schottky diode, or a low voltage. Is it as... Why can't I say Scotch Schottky? Schottky. Schottky. Is it Schottky diodes or Zener diodes I want? Schottky and Zener. Main difference. Schottky diodes, well, Schottky diodes and Zener diodes are two different types of diodes, yes. The main difference between Schottky and Zener diodes is that Schottky diode is made of a metal semiconductor junction, whereas a Zener diode is made of a p-n junction of two highly doped semiconductors. So Schottky is metal, whilst Zener is metal. The reverse currents will be larger, but we will rarely have reverse current since it's pretty much always going to have the light on unless it's communicating. Oh yeah, Zener is you use for cutting a voltage basically. It has that classic reverse characteristics that people use to cap voltage or sheep voltage supplies at some X amount of volts, or to be as a voltage reference actually. However, we want a Schottky, I think. Schottky barrier diodes? What's a Schottky barrier diode? And this a disconnected pin. Nice. Hey, look, an actual diode. Again, huh? Oh. These are just these, but defective. Or half defective. Interesting. What is a Schottky barrier diode? So the Schottky barrier is the phenomenon that the Schottky diodes work upon. Okay, I assume. So JSC PCB assembled. What you got? 2 diodes. Excuse me, $2 for a fucking diode? Minimum one. Basically. What? Bruh. Why? 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 Okay. Now, solar sense. The voltage we're gonna have is about 1.5 volts. I'm gonna need a transistor. Sure, Darlington. We can go with a Darlington. Oh, it's expensive. I hope these aren't big. I mean, they're freaking expensive. Almost $1 a pop, like $half a pop. Excuse me, what? Are these having some massive rating or something? Check their specs. 100 volts, 8 amps. No. Nah. 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 Ah, yes. Yes, that's more like it. Let's check what this is. It's NPN. That's that much I could see. It's NPN 500 milliamp with a collector emitter breakdown voltage of 30 volts. Maximum power of 350 milliwatts. I think we can use these transistors for everything. Let's see, we have to stay under 350 milliwatts. And let's see how much of that we are going to use. So, potentially, when the motors are stopped, they can, let's assume they pull 500 milliamps. We're going to be doing that at 1.1 volts, roughly, 1.15 volts, 1.2 volts, 0.6 watts. That's double. Well, what do they pull when they're stalled? I think I stalled them before on, I think it was 3 volts or 2 volts, and I think it was 200 milliamps. This is a Darlington as well. Check the data sheet. So 23. I was about to say, like, where's the specs, mate? Collector base voltage 30 volts, collector emitter voltage of 30 volt, emitter base voltage of 10 volts, absolute maximum ratings, yes, of course, yes. So, characteristics. Emitter cutoff currents at a 10 volt between emitter and base. Maximum 100 nanoamp. Now what's interesting is probably collector emitter saturation voltage 1.5 volts. With a current of 100 milliamps on the collector and 0.1 milliamp on the base. Ah, oh, ah. Huh. Hmm. The thing is, you might get too sensitive. Actually, no, it won't, because these transistors, they will not respond below, well, 0.7 volts or so. I think. Not sure, actually. Maybe that's what... is there a cutoff voltage? NPN. Yeah, it seems I think I'm correct in that assumption. I'm fairly certain. But yes, I think we will use that. Really? Why? I don't get it. Whatever. I'm only gonna ever need one of those nodes. Now, I probably want that directly hook into ground on the emitter. Like so. And have this be on the pull-up on the ESP. I wonder, ESP pull-up resistor value. Let's ask Google, since DuckDuckGo seems to be fairly stupid when it comes to technology. Well, electronics, I mean. This doesn't state ohm values. Offensive. High Z. ESP8266 hardware development kits. Yes, it's the ESP8266. 8266. And it's between 30 kilo ohms and 100 kilo ohms. Nice. Which means however, that is not gonna be a weak pull-up when it boots. So I am probably gonna have to add in my own resistor. Chip resistor. 10 ohms. Nah. Can I get like some stupid value of like yeah, 2.4 million ohms. Yeah. The thing is, the weaker you make the pull-up resistor, the more power efficient it's going to be, because it's not going to piss away as much energy by just sitting there and being a resistor. However, the more resistance you add, the more susceptible the system becomes to noise. So at some point you gotta say, yeah, that's enough. Ooh, I didn't check extended or God damn it. Minimum of 100, bruh. Still 0.1 cents for 100. Jesus, that's literally pennies. $20K, how about that? 0.2 cents. Well, $0.2 for all of them that I will use. Fuck it. They're free anyway, basically. If I have one on there, I can have that many on there and it's still free. So the price doesn't go up. I have to use quite a few. So actually, let's see if there's any 10K ones. Uniohm. They are cheap, okay. R1206 versus R0603. R603 is so tiny. It's insane. So we'll go with that. And there we go. We have 20K. Actually, hell, 30K. Still minimum 100, yes. But 100 times 0.0008 is still only 8 cents. I like that. That's a nice price for a resistor. So yeah, sure, we got 30k to our pulled up pin, which will add another 30k at most. No, at least, and 100k at most. So when it comes to noise, we're gonna calculate on the 100k. When it comes to current, we're gonna calculate on the 30k, which is the worst in both cases. And that's how to engineer, really. It's quite simple. Depending on how you define simple, but that's not for me to do, I think. Good spot. Good catch. I didn't even see that. This is gonna be like, yo, I'm just gonna short to ground, y'all. That's not what I wanted. So, 20k. Probably don't need 20k. Thing is, thing is, depending on where I put these resistors, either here or here, I don't know where, but that might affect how the transistor enters saturation, or if it enters saturation or not. How much current are we wasting? from the panel. Let's see, we have 1.5 volts. We are gonna drop what's the base emitter voltage on this? Two volts. Okay. Oof. So it's 2 volts for this transistor, but it's usually 0.7. Because it's a Darlington. So how did they get it so cheap? CJ, you gotta catch the train, CJ. Catch the damn train, CJ. These two are the same footprint, but are widely different. Oh, yeah, one is NPN, one is PNP. Huh. I'm just gonna place it. And we will check the specs. NPN 1.5 amp, 225 volts, 300 milliwatts. So the emitter is the big terminal. Base emitter saturation voltage is 1.2 volts. Collector emitter saturation voltage is 0.5 volts. Base emitter saturation voltage will basically be down here in the milliamps for us. Well, it will be down here in like 0.7, 0.6 volts for us at 10 milliamps. Yeah, I like this. This is a plastic encapsulate transistors. I like this signal transistor. I think it's a signal transistor. It seems so with these tiny cutoff currents and voltages. But it is only up to 30 megahertz. I think that's what that means. No, wait, what? Transition frequency at 30 megahertz is 100 megahertz? What? I have to look up what transition frequency is, but that doesn't matter because we are not gonna do wavy signals and frequencies. We're mostly gonna be monitoring a static light that sometimes goes beep 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 beep. And that isn't really in the megahertz, so we do not even need to worry, I will say. Okay. Okay. Yes, I think that's a good transistor. It seems to fit the bill. It has the low voltage requirements. Yeah, I will keep ground on this side. I was not prepared for that. And neither were you, I guess. I bet. I guess we will reuse this transistor for the drivetrain as well then, for the H-bridges. God damn it, I have to design. Last time I did H-bridges, they went a little boom. I guess we're gonna keep using our 10K. 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 Bum, ba-dum, ba-dum, ba-bum. Bum, ba-bum, ba-dum, bum, 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 ba-bum, bum, bum, bum. Bum, 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 bum. Bum, 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 bum. Can I flip this? Thank you. I didn't need that text there. Now, traditionally, this is how you connect an NPN H-bridge. Or we could make these bottom ones PNP and instead do if they are PNP, you can instead do this and just hook them together like that. But I think I'll stick to one type of transistor, but last time I said that while making one of these, it didn't go so well. So, well, there's 10K there. Oh, oh, Scheiße. I just remembered. This is the wrong data sheet. Here's the thing. Collector emitter saturation voltage. We need to have that. We need to have at least 0.5 volt from the collector to the emitter. And if we look here, we're gonna have to have 0.5 volt from there, this point, to there, and also 0.5 volt from here down to here. So we're gonna have to have 1 volt at least over the whole of it. But that was under a specific condition. What was those specific conditions? Collector current of 800 milliamps and a base current of 80 milliamps. Collector emitter voltage. So with our current, our emitter voltage rises and then stabilizes. Oh, okay. So we're going to be aiming for a collector emitter voltage of 0.5 volts. Let's just say that. And each here, where we hit these lines, is what the base current is and what the actual collector current we get. So if we feed in 500 microamps, we get over 120 milliamps at 0.5 volts CE. That's not too bad. We just have to drive it harder to make sure the collector emitter voltage stays down here. Base emitter saturation occurs at 0.6 volt for 1 milliamp. We're probably gonna maximum reach 100 milliamps, which is 0.7-ish, well, almost 0.8 volts. We're definitely going to do that with a 3.3 volt supply and a resistor. I think this will work. Maybe, perhaps. I don't know. I'm just so afraid of fucking it up again, because every time I made a H-bridge, they just haven't worked. Especially these designs, where I basically go boom, 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 boom. So that's the left side. And this will be the right side. Okay. Oops. Eh. Half of the design is designing the document. To not have yourself go apeshit crazy. Yeah. Gives us a little area to work in here. But I think that's actually it. That's all the circuitry. I think I might just do that for simplicity. Yeah, we have motor and we flipped the right and left on them. Ra motor left, motor right. I swear this is this is just not gonna work again. I swear it. I could I. But yes, that's the circuitry right there. All in all, it's 9 transistors, 12 resistors, and 1 diode, and miscellaneous components. Yeah, I forgot to put NC on you. Please associate footprint first. Looks like I'm only using these. So, we wanted it to be what did we say? 32.5 by 29. I'm just gonna open a notepad quickly. And I will try that again. And there it is. We're gonna have to fit all this onto here. Oh boy. Which resistor was charged? Q1. Where are you, Q1? There, of course. Of course it's smack dab in the middle. So, this was foo, correct? So it is wider than it is longer. Yeah. So the motors will either be here or here. It's important to get your orientations right. Ooh, I didn't put in an on switch. Do I need one? Is the question. Because I'm planning on having the ESPs removable, so that I can put a bunch of components underneath them. Like build on height. Thing is with that though, I never experimented on how tall that might actually become, which is kinda oof. Eh. Where would it even be? Where would I even put the power switch underneath the panel? I mean, yes, the panel's gonna like flip up-ish, because it's not gonna be glued in, at least in the beginning. Tell you what, I will I will add it in. However, I don't see it as strictly necessary. Yeah. If anything, that's what we'll go for. So either just solder that over. Ooh, I kinda just realized that most of these should have SMD pads. Oh. Eh. Eh. figured out a new hotkey. Hurrah. That one, that one, that one. Now use these ones. Hmm. Why? Save and update PCB. Components. Shade stuff. There we go. What is this? Is that the diode? I hope you're shitting me. That's a huge diode. We need to find a different diode. This one is too big. Do I want SOP 23? Isn't that what these packages are? SOT 23. Okay. SOT. Okay. I just want a diode, man. Huh. You know, I should probably check in JLC PCB assembled and do then Schottky. extended. Stop that. Or you have to check that the other part isn't extended as well. Now, a Schottky diode is a Schottky diode, so basically anyone will do. Let's check this one. 40 volt, 1 amp, 550 milliwatts at 1 amp. Schottky barrier diode. ROS compliant. And its characteristics are as follows. Schottky barrier rectifier. Is it specialized as a rectifier? This is like mains stuff. Why? At 0.3 volts, we have 100 milliamps. Essentially. Okay, maximum non-repetitive peak forward surge current. 24 amp surge. 1 cycle. 12 amp surge, 10 cycles. Reverse voltage is 20 to 200 volts with this series. Uh, I don't really make sense of stuff. There's also conjunction, majority carrier conduction, low power loss, high efficiency, built-in strain relief, idea for automated placement, high forward surge current capability, high temperature soldering guaranteed. I mean, technically, it's all fine. Because it can block reverse 20 volts regardless of which one I chose. SS14 and yeah, so 40 volts it can block. It can supply an amp at whatever voltage. Rectified current. This thing is like, they assume it will only be used as a rectifier. Why? Fuck it. Ah, sneaky. The curve above is for reference only. But yeah, 14, that's the solid green one. Forward voltage, 0.3 volts at 100 milliamps. It's funny because this is rated for mains voltage, essentially. Well, not this specific one, but forward voltage, maximum 550 millivolts at 1 amp. Ooh. 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 Whoa. Yeah, I think I will go for this SS14. Yoink, and you are now back to being diode 1. Yay! 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 Here it is. That goes to power enable along with stuff. I'll probably just overlap them like that. Or, I don't know, we shall see. With this, is our sensing solar. I'm hoping to cram a bunch of the transistors and stuff underneath the ESP here. Hopefully that is doable. But I think this is a good spot to take a break. everything is basically as I want it. The only through-hole components are well, the connectors for the ESP and for the boost converter. Where is this little boost converter? There it is. Here's a little boost converter that's gonna sit in that 3-pin. Do I have a ESP? I do. Come here. Okay, both of you. And here's what's gonna sit in those 8 holes. There we go. So we're both on 2 boards. 2 ESPs and 1 little boost converter. But yeah, those are the only through-hole components that we will use. The rest will be surface mount. Oh, and carpentry. I forgot to check. Can I get a bomb? No. You bastard. Thing is, I don't know if all of these are, oh yeah, they're SMT type. Basic, all of these gonna be basic. R1, basic. All of these are basic. That is our ESP. So the resistors are basic. The transistors are basic. Header will not be supplied by them. And the diode is basic. Okay, everything is basic. Ugh. Everything is basic, everything is handy dandy. Good. And yes, we'll take these and do something like this later. Yes. What? Don't save. What was that? That was weird. But yes, I will take a break and we will actually design this soon, hopefully. We will split it all up and then cram it all in here in a sensible way, whatever sensible way means. But most of that sense will go to where these end up. Like I assume something like this, because motor, well, technically that way. So you got motor right, left, like so, and their connector is going to be in the center here somewhere. But then what I do with the battery and the solar, I don't know, I want to split them up maybe, so that I got 2 ground pads here and then the battery pad here and the solar pad there. I kinda want to do that. And I might actually switch these back to individual pads too. I don't know. Either way, I will design the rest of that later. For now, I will take a break. See you in a few hours, or an hour, or whatever. Oh Jesus, we've been streaming for 2.5 hours. Well, I'll take something to eat, and I'll be back.